Hi, everybody. Happy Friday. So today we will continue to talk about 9.1. And this afternoon we have study session. It's here from 3:10 to 5. So print out your practice exam and come and work on it. And you can ask me questions on your homework, the in-class notes, and the practice exam. Okay, so last time we did the quiz and the homework. So let's go over the quiz. Okay. So this quiz is about sessions 8.3, inverse trig function, right? So there are two types of problems, right? You have inverse trig function outside and the trig function inside, or you have the inverse trig function inside and the trig function outside. Right, everybody? So in the exam, I have 6 choice for the inverse trig functions and 6 choice for the trig functions. So be prepared for any combinations of those. Okay. So the method how to solve these two types of problems are different. Okay. If the inverse function is outside, then you need to draw the graph of the trig functions, right? Okay, look at this problem. We have the angle. So we look at it from the inside to the outside. Inside, the input is an angle, right, everybody? And cosecant apply on this input, the angle. The output is a ratio, right? It's a number, it's a ratio of two sides of a triangle. And then when we apply the tangent, we will get an angle. So your number, your final answer is an angle. Okay? So we look at this inside angle 9 pi over 2. Do you see this is not within 0 to 2 pi? Right, everybody? Because cosecant is the period is 2 pi. So that's why we want to find a coterminal angle within 2 pi. So what do you usually do? Because it's positive, you subtract 2 pi to see if that is enough. And you realize that if you subtract 2 pi is like 4 pi over 2. And 9 pi minus 4 pi is 5 pi over 2. And 5 pi over 2, is it in 0 to 2 pi? Not yet, right? So which means we need to subtract another copy of 2 pi. So that's why here we need to subtract 4 pi, okay? It's 2 copy of 2 pi. And 4 pi is 8 pi over 2. So 9 pi over 2 minus 8 pi over 2 is pi over 2. Yes, everybody? Step 1, restrict your angle within 0 to 2 pi. And then cosecant. You look at cosecant, it's the reciprocal of sine. So remember, you only need to know the sine, cosine, tangent, and cotangent. If you see secant or cosecant, you can relate it to sine or cosine. Okay? So we draw the graph of sine. And this is the graph of sine. And we can see pi over 2. Sine pi over 2 is 1. Yes, everybody? And then the cosecant is 1 over sine. So 1 over 1 is 1. Now, at tangent of 1, what is it? Okay, this is the inverse function of tangent. So we draw the graph of tangent. And remember, the x of the tangent corresponds to the y of the tangent. Because inverse function, you just switch the x and y. So you let the y equals 1 and find the corresponding angle. Do you see that angle is pi over 4? Yes, everybody? So that's why the final answer is pi over 4. So in the exam, I hope you can show all the steps. Okay? So yeah, it usually 2 trig functions are involved. Draw the picture and show me how do you use the graph to find the answer. Okay? For example, if here instead of pi over 2, if you have like 3 pi over 2, 3 pi over 2 is here. Then you know the sign will be -1. Right, everybody? And the cosecant will be 1 over -1 is still -1. But the arctangent of -1 will be negative pi over 4. Right, everybody? Okay, so this is problem number 1. When you have the inverse trig function outside of a trig function, you draw the graphs. Is that clear, everybody? Second problem. If you have the inverse trig function inside and the outside is a trig function, one method, draw the triangle. And this method works for all types of trig function and inverse trig function. Okay? And what do? So cotangent, the input is a ratio and your output is an angle. Right, everybody? So you call this angle or argument be theta. Well, this means theta is arc cotangent 11 over 5x. So cotangent theta is 11 over 5x. And cotangent is adjacent over opposites. That's why we let adjacent be 11 and the opposites be 5x, right? And then the Pythagorean theorem, hypotenuse, because it's the longest side, right? So it's the square root of the adjacent square plus the opposite square. So you get plus here. And finally, we are looking for secant theta. Secant theta is what? Hypotenuse over adjacent. The hypotenuse is square root of 25x squared plus 121 over adjacent is 11. Is that clear, everybody? So you don't need to memorize the page of formula. You don't need to. Just draw the triangle. Okay? All right. So let's look at the mistakes. So here, that's the correct answer. But how do you use the graph to find this answer? So show all the intermediate steps. Like what is this? What is 9 pi over 2? You see 9 pi over 2 is not here. So you find the coterminal angle between 0 to 2 pi. Okay? Then find the cosecant. Okay? And we know this is 1. Then arctangent of 1. So where is 1? Here. And the picture you need is from minus pi over 2 to pi over 2. Okay? And then, get the final answer. So please watch the recording for we went over the quiz solution. Okay, and here we have 25x squared. Oh, please watch the recording. So we went over the quiz solution. So now we're talking about the quiz mistakes. And here, when you copy the problem, be careful, okay? And this is not the correct method. So please draw the triangle. You don't need to memorize the formula. Okay, bye. Thank you. I almost missed that. Formula, I mean, Okay, so what's the formula? So I know there are so many different ways to solve these problems, but imagine on your exam you don't have any formula sheets. I mean, we have the blank one, but it's blank. Uh, so let's see. Yes, this is a formula. I mean, do you want to memorize them? Are you able to memorize them? Are you able to memorize them? No. No. That's why don't use the formula in your quiz because in the exam you don't have any formula sheets here. Okay. By the way, if you're late, please watch the recording. We just went over the solution of the quiz. Okay. So now we are looking at the mistakes. So that's why don't use the formula. Okay. Draw the triangle and complex number. No, we don't touch complex number in our course. Okay, so look at your review your notes before you do the quiz. Okay, and come to ask me questions. So this afternoon we have study session here from 3:10 to 5 p.m. Please come, okay? Because you can feel like second exam is harder than the first exam. If you use the wrong methods, you lose most of the points. Okay, so please come. All right. And then here, so draw the triangle. Okay, so draw the triangle. So the method, yeah, very important. Okay, so here, correct answer, but don't combine them because they are not like terms. So don't combine them. Just leave it like that. Okay. So yes, we learn from our mistakes. Okay. So mistake help us improve. So I hope in the exams that you get better scores. Sometimes I make mistakes too. We're all human beings. So that's okay to make mistakes, but we just learn from it. And then here, be careful. You mean secant theta is this number. This is the output, not the input. So be careful. Yeah, you mean secant theta is this number. So be careful. And here, yes, x squared. And then here, secant squared is 1 plus tangent squared. Okay? And yeah, you can use this method, it works. But the mistake is this is tangent squared. Okay? So here, this method is using the trig identities. Yes, you can certainly do that. And here, so you subtract 2 pi because the cosecant is a 2 pi periodic. Subtract pi is not enough. So you subtract 2 pi. Then you realize, 5 pi over 2 is not enough because it's not in 0 to 2 pi. So you need to subtract another copy of 2 pi. Okay? So we get pi over 2. So pi over 2, which is here, and you get the, thank you, you get the arctangent is positive 1. And that's why it's positive pi over 4. And here, Pythagorean theorem, hypotenuse is the longest side. So it's the square root of the sum of the square of the other two sides. Okay, so be careful with that. And here, x squared, and also plus. Oh, and that's it. So any questions about the quiz? No? Okay, so I hope to see you in the afternoon study session. Okay, especially the student didn't get over like 7 points in exam 1. I really care about you. I want to make sure you understand every problem in your class notes, in your homework, and in the practice exam. Okay, so any questions before we continue 9.1? Okay, so exam. When is the exam? Monday. And it's from so I will come here like at 8:50. So feel free to come here earlier. And I have another class have exam here from 10 to 10:50. So if you need more time, feel free to stay longer. Okay, everybody? Yes. So and maybe in the middle of your exam, my next class student will also come early to start their exams. But it's okay. I assign the seat so you can, yes, follow the seat. All right. So 9.1. Last time we talked about all these trig identities. Remember? And you use the hexagon to help you to memorize the diagonals, identity, and the triangles identities, right? So let's continue. Problem 3. Simplify the following. Okay, so usually when you see simplify, what does that mean? What does it want us to do? So if you see something you can factor it. Or if you see something you can like use the trig identity to simplify. So like reduce the number of trig functions. Okay, so if you can like express this in terms of like a shorter expression, that would be good. So look at this problem. Can you see we have a common factor sine x? Yeah, so let's factor out sine x. And then what's left? The first term, you factor out sine x. What's left? Cosine square. And then minus 1. Right, everybody? Mm-hmm. And then, oh, what else we can do? Cosine square minus 1. This session, it requires you to be very familiar with the trig identities. If you see cosine square and 1, what can you think of? So the reciprocal identity, maybe it's, yeah, the triangle formula. Yes. Maybe it's better to look at this one because this one you are more familiar with. Right, everybody? And do you see the reciprocal is all the power is 1? And you see the triangles, all the power are square. So if you see square and 1, then you look at the triangle identities. Yeah? And which one has the cosine square and 1? The first one. So we use that. Okay. So the first one, we have sine, and the angle could be anything. In this case, the angle we need is x. So sine square plus cosine square equals 1. So how do you change it? So one side, you get cosine square minus 1. What do you do? We want to have one side is cosine square minus 1. So what do you do? Subtract 1. Yes. So if we subtract 1 on both sides, we get sine square plus cosine square minus 1 is 0. What do we do next? Yes, subtract sine square. So we get cosine square minus 1 is negative sine square. Yes, everybody? Oh, it's negative sine square. So we have sine x, and then the second factor equals negative sine square. Do you we use trig identity to make it shorter, to reduce the types of trig functions. Okay? And can you combine them? Bless you. Can you combine them? Sine times negative sine square is negative sine cube. Right, everybody? So that is simplified. If you can factor, factor it. And then if you see some trig identities, use it to reduce the types of trig functions. Is that clear, everybody? Mm-hmm. All right. So this is number 3. Number 4, rewrite secant plus cosecant in terms of the sine and cosine function only. So this is a usually people want to express the trig expression in terms of sine cosine because we're more familiar with sine cosine. Okay, so last time we say all the 6 trig function we can express in terms of sine cosine, right? You know, sine is sine, cosine is cosine, but tangent is what? Sine over cosine. Cotangent is cosine over sine. And secant is 1 over cosine. Cosecant is 1 over sine. So everything, all the 6 trig functions, you can express in terms of sine cosine. And this is usually a common method because there are a lot of trig identities. Which one shall we use? Express in terms of sine cosine. Then it's easier to simplify, and you know the trig identities involve sine cosine. It's just sine squared plus cosine squared is 1. Okay, everybody? So let's see. Okay. So, what is secant? 1 over cosine. And what is cosecant? 1 over sine. Right? And usually people want you to combine them into a single fraction. So how do we combine them in a single fraction? Well, it's the common denominator. Yeah, cosine times sine. Yes, everybody? So combine them and look at the first fraction. How do we get the common denominator? We multiply the top and bottom by sine theta, right? The second fraction multiplied by cosine theta. So this is how you add fractions, right? Okay, you're not adding the numerator over you add the denominator. You're not like that. You find the common denominator, then multiply the appropriate factor by the numerator and denominator, so you have the same denominator. Then you can add the corresponding numerator. So what is the numerator? Yes, good. All right, everybody. So this is number 4. Okay, number 5. Factor each expression. Okay, how do we factor? So you learn factor from like algebra, right? Did you take algebra last semester? Yes. Okay, then I hope you still remember how to factor. Okay, so here are some formula. If you see a squared minus b squared, difference of square root, difference of square, how do you factor? Yes, a minus b times a plus b. Good. If you see a squared plus b squared, can you factor? No, cannot be factored. Okay, so a squared plus b squared cannot be factored. A squared minus b squared, yeah, you can factor. And if you have like a plus b squared, this is what? A squared plus 2ab plus b squared. Right, everybody? We have the middle term, the 2ab. You still remember? And many mistakes, it would be like just a squared plus b squared. No, you have the middle term, the 2ab. If you have a minus b squared, then you have a squared minus 2ab plus b squared. Right, everybody? Okay. Do you still remember these? A harder one. A cubed minus b cubed. How do you factor? So this is degree 3. Do you agree? It can be factored as a product of degree 1 terms and degree 2 terms. Degree 1 term, they're like power 1. So it's a minus b. So you see the sign here is the same. And then the second factor, they are all degree 2. What are the factors with degree 2? A squared, ab, and b squared. Right? And guess what? The middle term, the sign is gonna be opposite. So if this is minus, the linear factors, they have the same sign, it's minus. But the quadratic factors, the sign will be opposite of that. So this is plus. Is that okay, everybody? Do you still remember these? And if you have plus here, then the first one is plus, the second one is minus. Only change the sign of the middle. Right? So this is how we factor. Now we continue to solve the examples. Secant squared minus 1. How can you factor? So something squared minus something squared. This one, right, everybody? We have a squared minus b squared. So with your a is being secant x, your b is like 1, right? So we got a. What is a? Secant x minus b. B is 1. And then a secant x plus b is 1. Is that okay, everybody? Yes? Mm-hmm. Okay. Why we are doing this? We're still building the foundation of solving trig equations. In session 9.5, we will solve equation involving trig functions. So at that time, what you're doing, so you might have an equation like secant squared minus 1 equal to 0. So you factor them and you set them equal to 0. It means your first factor is 0 or your second factor is 0. And then you solve for secant x. Do you see this is the same as secant x equals to 1? Yeah. Then you use the knowledge we learned from 8.3, the inverse trig function. Then you can find which x values give you secant x is 1. Okay? So we're still learning more and more and more. In the future, we'll use all this knowledge to help us to solve equation involving trig functions. Okay, so this is why we are doing this right now. Okay, and then B. This is 4 tangent squared plus tangent minus 3. Okay. If you're not, so this is like a quadratic type function, and you have the tangent is involved. Okay, so if you're able to factor, you can factor like directly, Or if you want to do it slowly, you can do a substitution. You can let u be the tangent x. And then you get 4u squared plus u minus 3. Okay? So it looks easier. It looks easier. It's a quadratic expression. Then how do you factor a quadratic expression? You put look at me, yeah, we do those. You put a pair of parentheses. And you look at the factors of 4u squared. They are either u or u and 4u, or they could be 2u and 2u. Right, everybody? And let's pick one of them. So let's pick 4u and u. You put it, yes, on the left side of the parentheses. And then you look at the constant term, -3. What multiplied together is -3? Yeah, it's -1 and 3, or it's 3, or -3 and 1, right? But we don't know which is which. Okay, let's try. If we put -1 here and 3 here, let's see if this works. So we multiply the outside. We get what? 12u, and you multiply the inside, you get -u. And when you add them, what happens? It's 11u. Is that the middle term 11u? No. So we should not put the -1 and 3 over there. So let's switch them. Okay, we switch them. Let's put the 3 here, and we put the -1 here. Let's try that. We multiply the outside. What do we get? -4u, right? We multiply the inside. What do we get? 3u. When we add them, what do we get? We add them. -u. You see this is not -u. This is u. If your answer is only differ by a sign, it means switch the sign. Okay? So put this as negative. So it's -3, and put this as positive 1. And then multiply the outside, we get 4u. Multiply the inside, we get -3u. So is this how you learn factor? You feel free to use different methods. There are so many different ways to factor. Okay? So, all right. Therefore, good. We plug the u back. U is tangent x. And u is tangent x. So if you're familiar with factoring, you can jump from here to here. Okay, I'm letting u to be tangent x, so you get an easier expression, and then you can factor. Okay, but it's up to you. You jump from here to here if you can see how to factor. All right. Okay, let's see. Continue. What if? So the part B, we have all the expressions in terms of tangent. Part C, we have some cotangent and some cosecant. What do we do? Okay, remember cosecant and cotangent are related. What is the trig identity involving cosecant and cotangent? Which one? Which formula involving cotangent and cosecant? Here, right, everybody? So we got cotangent square plus 1, bless you, is cosecant squared. Right, everybody? And now we think. Can we express the cosecant square in terms of cotangent, or we express the cotangent in terms of cosecant? So So if you express cosecant square in terms of cotangent, you replace this by cotangent square plus 1, right? So we get a nice expression. But if you try to express cotangent in terms of cosecant, guess what? To find the cotangent, you need to move the 1 over and you need to take square roots, right? Do you want to have a square root in your expression? No. So in this case, we must express cosecant in terms of cotangent because we don't want to have the square root inside. Okay, everybody? So sometimes if you don't know what to do, try both and see which one works and which one does not work. Okay, so cosecant square is cotangent square plus 1. And so this is the cosecant square. We still have minus cotangent x and then minus 1. Can we combine the like terms? So we order from the highest power to the lowest power. What is 1 minus 3? Negative 2. Okay. Now you factor it. Do we factor it? Oh, when you multiply you get 2 and then minus 1, so it's positive 1. And your sign is negative, you just change the sign. Yes. So you look at which one is outside. If you have the angle is the arc outside, you draw the graphs. If it's a trig function outside and the arc inverse trig function inside, draw the triangle. Okay. So what is your answer? Yes, good. Because we multiply the outside, we get cotangent x. We multiply the inside, we get -2 cotangent x. So when we add them, we get -1 cotangent x. Is that okay, everybody? Yes? All right. Continue. Number 6, simplify. So we want to simplify this expression. Okay, again, what does simplify means? If you have two fractions, you want to combine them into a single fraction. So here it means combine into a single fraction. Okay? And let's see here. We have the common denominator is what? 1 plus cosine x and sine x. Right? When you add two fractions, you find the common denominator. And look at the first fraction. How do you get this? You multiply the top and bottom by sine x. Right, everybody? How do we get the common denominator? We multiply the top and bottom by sine x. Right? And the second factor, we multiply the top and bottom by 1 plus cosine x. Right, everybody? So we have the same denominator. Now, what is the numerator? Sine x times sine x is sine x squared. And you have cosine x times 1 plus cosine x. Right, everybody? And now, what can we do? Distribute. Okay, so next, distribute. And see if you can combine the like terms to simplify, right? Okay, let's distribute. We have sine squared. If we distribute, what is cosine x multiplied by 1? This is cosine x. And what is cosine x times cosine x? Yes, cosine x squared. And do we change the denominator? No, just copy it. All right. Do you see something familiar? Sine and cosine. What's the trig identity? Yeah, triangle formula. We have sine squared plus cosine squared equals 1. Right. You kind of understand why I asked you to be familiar with the formula. Because if you're familiar with the formula, you know what to do. If you're not familiar with the formula, you don't have a direction. Okay, so that's why it's very important to be familiar with all the trig identities. We get sine plus cosine. See, sine plus cosine square is 1. So therefore, the numerator is just 1 plus cosine x. Yes, everybody? Because sine squared plus cosine squared is 1. So we have 1 plus cosine x. Oh, what happened? Cancels. How nice. We get what's left on the numerator. Yeah, that is cosecant x. We can simplify that complicated expression to a single trig function. Right? So what's simplifying? If you see fraction, combine into a single fraction. If you see something, you can distribute. Yeah, distribute and combine like terms. And if there's some way you can use the trig identity, please use that. And so you can cancel. Okay? So you can cancel something. And at the end, you see 1 over sine x is cosecant x. So you can express your answer in just a single trig function. Is that okay, everybody? Yes. So this is what it means, simplify. Simplify. It really depends on what the problem looks like. Okay? It may be factor, it may be combine them. Yes. Okay, so do that this session. I hope you can do a lot of examples. And here, verifying fundamental identities. Let's talk about all of these, and then we'll do the example next class, Wednesday. So hints for verifying identities. All these are hints. Learn, i.e., memorize the fundamental identities from section 7.1. Okay, yeah, I think 9.1. Yeah, 9.1 or 7.1. The fundamental identity means this. Okay, and we have been practicing them a long time. Okay, and be aware their equivalent forms, like the rearranged Pythagorean identities. Try to simplify the more complicated side until it looks like the simpler side. And usually, verifying identities means you have equation. And like here, you have an equation. And you want to show the left-hand side equals to the right-hand side. Okay? And sometimes it's helpful to express all trig functions in terms of sine, cosine. That's why we practice that. And we're familiar with sine, cosine. Yeah? Sine squared plus cosine squared equals 1. And then simplify. Usually it helps to factor when possible and perform any indicated algebraic operation. For example, if you see something like this, right, like a squared plus 2a and plus 1, this can be factored as sine x plus 1 squared. Okay, so factor them. And if you see sum of two fractions combine into a single fraction. As you make substitution to convert one side into the other, always work toward the goal of the other side. A common trick is to multiply expression like 1 minus sine x by the following fraction, because the Pythagorean identity can be used to simplify. This guy, we call it conjugate. So, do you remember complex numbers from your algebra class? If you have a plus bi, the complex conjugate is a minus bi, right? You multiply by the conjugate, so you can get rid of the I in the denominator. So here is kind of similar. If you see 1 minus sine x, you multiply by the conjugate. Conjugate is you change the middle sign from minus to plus. And the trick is 1 minus sine times 1 plus sine is a formula a minus b times a plus b is a squared minus b squared. So you get this is 1 minus sine squared, which is cosine squared. Okay, everybody? So this is one of the common trick. Yes, so let's do examples on Wednesday. When is the exam? Monday. And this afternoon we have study session. So hope to see you. Yeah, 3:10 to 5 in this room. Yes.
Why is it 3:10 and not 3?
Oh, because I teach from 2 to 3:07. Yep. Mm-hmm. Bye. Have a good day. Yeah, sure. Thank you.
And then for Monday, because I'm taking it in here instead of the OSS because they probably effed me over last exam.
So you would take
So
it here?
I'm taking it in here to see if this is better for me.
Yeah, I think that would be okay because
And
my next class is also have an exam here.
Okay.
You can stay as long as you want until 11.
Yeah.
Yeah. So I think that would be good. Okay, good.
My bio teacher can just screw over a little bit. She'll know.
Okay. Bye.